In 1997, Andy Green broke through the sound barrier in the jet-powered Thrust SSC. He earned a place in the record books. But was he really the first? This is what driving at the speed of sound feels like. Because the speed of sound varies according to the temperature of the air, it's known as Mach 1. On land, Mach 1 is between 720 and 760 miles per hour. The challenge to be the first to reach Mach 1 on land was taken up by two men, American Craig Breedlove and Briton Andy Green. They both followed the strict record rules set down by the FIA, a world motor racing organization. In October 1997, Andy Green won the contest in Thrust SSC. He achieved the first official supersonic world land speed record. He made 2 supersonic runs within 1 hour, and his average speed was 763 miles per hour, Mach 1.02. This incredible achievement was celebrated around the world, and Britain honored Andy Green as a hero, the first man to break the sound barrier on land. But what the world had forgotten was the extraordinary Budweiser rocket. This car was the creation of Hollywood film director Hal Needham.
The idea was it was a frontier that hadn't been climbed, and I just thought it'd be nice to be part of history.
In 1979, the U.S. Air Force confirmed that the Budweiser rocket broke the sound barrier. But because the team didn't run under FIA rules, their achievement was never officially recognized. This film hasn't been shown for 2 decades.
Okay, counting. 5, 4, 3, 2, 1.
The car was driven by a Hollywood stuntman, Stan Barrett.
You can ignore or reject the facts, but that does not change the fact that I went Mach 1, and I'm the first man to do that.
FIA rules were first formulated in 1914. They state that a car must run twice in opposite directions over a measured mile within 1 hour. The record speed is an average of the 2 runs, and the car must have a minimum of 4 wheels. The Budweiser rocket had 3 wheels. For Hal Needham, record rules were irrelevant.
I didn't see any sense in having to run 2 ways. What does that prove? Because you did it going that way, and now you did it going that way.
They simply wanted to use the power of their car to reach Mach 1.
When you touched the button on that thing, it was at full power, instantaneous.
As you're accelerating, the thing feels like it's going to break in 1,000 pieces. I mean, it's incredible. You think it's going to explode any second.
During his early runs at Bonneville Salt Flats, Stan Barrett reached 638 miles per hour, the fastest anyone had ever driven. For Hal Needham and Stan Barrett, it was a triumph, but there was still another 100 miles per hour to go to reach the sound barrier.
Why are you crying? Are you happy?
I thought how fast it was to have gone as fast as we had, and I went, whew, boy, this is not going to be an easy task.
To prepare for the increase in G-forces he would experience at high speeds, Stan put himself through a rigorous training regime. During the run at the Salt Flats, the wheels had broken through the surface. So for their supersonic attempts, they moved to Edwards Air Force Base. Here they switched to a new rocket engine, which would give them 48,000 pounds of thrust.
3, 2, 1, ignition.
The power of the car was awesome. But was there enough power to reach supersonic speed?
As we started getting up around that 700-mile-an-hour mark, it didn't take us long to realize that we didn't have enough power. So we went to the Navy and bought 6 Sidewinder missiles, without the warheads, of course.
One Sidewinder missile gave them an additional 12,000 pounds of thrust, but at incredible risk.
I didn't really like the idea of being coupled with that Sidewinder. It was mounted right behind my head, for one thing, and I was not real convinced that whatever brackets they had holding it were going to keep it in place, and I was kind of afraid when I fired it I'd lose my mind. The other thing about the Sidewinder was when you turn it on, you can't turn it off. So you're really committed.
On the first test with the missile, the car shot straight to 500 miles per hour in only 10 seconds. The extreme G-forces ruptured a disc in Stan's neck.
I don't know, I was so surprised that it hit me so hard.
Yeah, you're breaking up on that radio.
You get a lot of acceleration, period, then you hit that thing and it like tripled.
I thought, gee whiz, if this is the kind of acceleration I get, what's going to happen when you couple this with the hybrid engine? I didn't know whether I could take it or not.
Rather than use conventional land speed record timing devices, they recruited the help of the Air Force. The wing commander at Edwards was the fastest man in the air. Pete Knight had flown at over 6 times the speed of sound.
We had our people looking at every part of the operation to provide any professional advice that we could based on our experience. We did timing on every run with our radar on the base, the same kind of radar that we use in determining speeds and altitudes of aircraft with our instrumentation here on the Flight Test Center.
The next challenge was to test the car at maximum power. It was a tense moment for Stan's wife and family. Traveling at 1,000 feet every second, he reached a peak speed of 714 miles per hour, almost, but not quite, the speed of sound. The entire run took less than a minute, and Stan was safe. The next morning, it was cold, 20 degrees Fahrenheit. To break Mach 1, Stan would need to reach 731 miles per hour.
My major concern was Stan Barrett. Damn the sound barrier or anything else. Stan and I have been friends for years and years, and obviously I didn't want to kill him.
I feel if you're booked to burn, you're not going to drown, so I just went ahead with what I had decided to do and saw it through.
Stan, would you pray for us, please?
Sure will, Bill. Our gracious God and Heavenly Father, I thank you for this another day, and I just ask that you would watch over and care for my family, strengthen them, be with Bill's family and all the people that are supporting us. Thank you for their prayers, Lord, and thank you that you hear them. I just pray now for a successful run, and that you may get the glory for this, Father. In Jesus' name, amen.
If something went wrong, we'd have had to come out here with a bunch of sponges and try to find Stan Barrett. There wouldn't have been anything left of him, the car, anything else at that kind of speed.
mile and a half into the run, he fired the Sidewinder.
Once I hit it, I was really surprised again at the extra acceleration I got. I pulled another G at 640 miles an hour. And a few seconds later, I felt some pretty sharp buffeting, and then it smoothed out, and then it was like hitting a wall when the engines quit. The deceleration was pretty dramatic.
Stan had broken the sound barrier. As he approached Mach 1, his two back wheels left the ground. He'd come dangerously close to death, but he'd gone supersonic.
I'm going to announce what we got so far. We don't have Flanders speed. We ran out of fuel between 200 and 400 feet before the lights. We got 734 on radar, 739 on airspeed. We probably broke the speed of sound.
I think it was a fantastic achievement. I think it was outstanding. Just something that will go down in the history books as one of those significant events that happened in the history of speed. We did certify the car did go supersonic, and in fact I sent Hal Needham a message to that effect, and it was from the Air Force and certified by the Air Force.
Despite Air Force measurements, Stan Barrett's achievement was never recorded in the record books. His car had only 3 wheels, and he only ran in one direction. The official FIA record wasn't his. To achieve an official land speed record, you need somewhere large enough and flat enough to run safely in 2 opposite directions. In 1983, Briton Richard Noble arrived at Black Rock, Nevada. In his jet-powered Thrust II, he planned to break the official FIA world land speed record, which then stood at 622 miles per hour. On October 4th, 1983, he pushed Thrust II as far as it would go. On his first run, he reached a peak speed of 624 miles per hour. He had to make his second record run within the hour. His average speed from the 2 runs was 633 miles per hour. Noble had claimed the land speed record for Britain.
Was it all worth it?
Oh, God, yes. It's just beginning to sink in just what we've done.
Why did you do it in the first place?
Well, I suppose for Britain and for the hell of it.
14 years later, in 1997, Richard Noble returned to Black Rock Desert with a new car and a new driver, Squadron Leader Andy Green. To design and construct a supersonic car is one of the most difficult engineering challenges. The technology is completely untested. It took Richard Noble's team nearly 5 years to create Thrust SSC. At 54 feet long and 12 feet wide, it was the largest land speed car ever. 2 Rolls-Royce Spey engines provided 106,000 horsepower, enough thrust to accelerate this 10-ton monster to Mach 1 in only 65 seconds. To withstand the extreme stresses, the car was constructed around a solid steel frame.
The thing that it's very difficult for people to understand is that you're dealing with enormous forces, because you're talking about a dynamic pressure of 3/4 of a ton for every square foot of bodywork. Okay, so it's got to be very strong and it's got to be very, very heavy.
The aerodynamic shape made it impossible to build a steering mechanism into the front wheels. So the team experimented with the dangerous alternative of steering by the rear wheels. Their prototype convinced them that it could be done. Then the team began cautious, low-speed tests on an airfield in England.
What we have is a car here which is a research vehicle before it's actually a record breaker. You've got to be very responsible. The history of the land speed record is littered with people who just think it all can be done in a day, and of course that leads to disaster.
Andy Green, a fighter pilot, was undaunted by the prospect of hitting Mach 1 on land.
Going supersonic, for me, is actually a daily occurrence rather than something quite remarkable that somebody else does. The excitement of actually going supersonic in a car, the challenge of actually doing that, is largely a non-event. It's the controlling, the developing the car that's the challenge.
To continue with their high-speed tests, they needed a lot more space. Storms had covered Black Rock Desert in water, so the team traveled to the Al Jafr Desert in Jordan. Here they carefully monitored the car's performance and tuned the active suspension system. Mach 1 presented a new set of problems and unknown risks. No one was sure how supersonic speed would affect the car. It could flip over or even try to take off.
We felt all the way along the line that this was actually a stability battle, not a power battle. And it's very important. You've got to understand that the idea of the twin engines is not for power, but it's simply to put the weight in the right place and give us very good stability.
But Thrust SSC's controversial rear wheel steering and suspension system proved difficult to tame. There were some serious design problems. It took 5 weeks to reach the speed of just 330 miles per hour. But when the weather deteriorated, the frustrated team retreated to Britain. It would be another year before they could make another attempt to go supersonic. September 1997. The Thrust SSC team are camped at Black Rock, determined to enter their record books. Their long-term rivals, Craig Breedlove and his Spirit of America team, were also on the desert, but their camp was quiet. After 2 years of testing, the Thrust SSC team was quietly optimistic.
The Black Rock Desert is the perfect surface, the best anywhere in the world. It really is genuinely flat. There are no anomalies. You can drive across this lake at 100 miles an hour in a normal road car and feel absolutely nothing. You can sit there with a full cup of coffee and it will not spill.
Their record attempt was a massive operation with a huge team of helpers. One of the most painstaking jobs was preparing the desert surface, picking up tiny pebbles which could be sucked into the jet engines. Thrust SSC left deep ruts on the desert, so each new high-speed run required a further 10 miles of clear track. They prepared 30 parallel tracks, each 50 feet wide. Halfway down the track, a measured mile was marked out. Timing lights were set at each end of the mile. Before each run, the team had to be absolutely sure that the desert was clear of people and vehicles.
We ride up on the roof. Pits area will be Ashley and Guy. And Ray, you're with John on Access 5. You need to stay in position until you're called in by Jane.
Ranger Duty Romeo, message from Blackadder and Rattlesnake. The spectator issue has now been resolved satisfactorily.
At base camp, squadron leader Jane Millington, Andy Green's girlfriend, was in charge of communications.
That's copied. Stand by. VIP1, confirm ready.
The team's Pegasus microlights were sent up at the last minute to be 100% sure the track was clear.
The teamwork side of it is crucially important. If the team get to the point where they suddenly feel that that what they're doing is that they're sweating away like hell to make this man a hero, they'll just go. This is everybody's record. It's not one man's record.
September 25th. After 53 trial runs, the team hoped to beat Noble's standing land speed record of 633 miles per hour. Every precaution was taken. An air ambulance stood by. A high-speed fire response vehicle, a Jaguar, took up its position.
Pegasus, green and black in turn, confirm ready. I never really have time to think about the emotional. Emotion doesn't hit me during a run because I'm far too busy actually coordinating communications and actually arranging for the safety. So no emotion during the run, there's no room for it.
SC clear, set decimal 9, clear to roll.
The mile 700.661.
I read back the mile 700.661.
Okay, so we are actually on course for a world land speed record of 700 miles an hour. Now, do remember what he's doing is he's not driving the car as fast as it'll go. He is driving to a Mach number. Now, the interesting thing about this is if the temperature goes up any further between now and the return run, he'll come back faster.
Fuel, both tanks. Gauge stayed on, SI vent is closed for change.
Station call in position.
Okay, Nick, in your own time, you cleared one plug, panels on, chocks away.
Be lucky.
Bye. SSC ready to roll.
SC clear, set decimal 9, clear to roll.
130. Engines are good. 200. 1 mile into it. 4. Let's go. 550. The Howard 590, and it's going to 650. 670.
5 call 67.
3.6, we're going to shoot one.
Subject to confirmation, and that's how it has to be, we have a new world record for the mile at 714.144 mph, and a new world record for the kilometre at 713.990 mph. Hell of a day. This as a team is our first great success. Now we're going to push on to the next stage, which is towards Mach 1.
These guys have worked incredibly hard for the last 3, 4, 5 years to achieve this, and I'm absolutely delighted for all of them and for everybody at Sporters.
They were over the first hurdle, but this was just the start of the race.
We're here to break the World Land Speed record supersonic for the first time ever. So we've got a long way to go yet. We only did 92, 93% of the speed of sound. But we're certainly getting there, and in the meantime, it's a great boost to confidence for the team that we've just set a World Land Speed record.
It's great actually to be able to pass it on to your own team. I mean, that is just wonderful. And of course, to do it in such style, to have a situation where the new 714 mile an hour record is 80 miles an hour faster than my last one. I mean, that is the biggest jump in land speed record history. It's just a wonderful achievement.
Because of the air temperature, Thrust SSC needed to go at least another 40 miles per hour faster to break the sound barrier. But it was to be a dangerous journey into the unknown. The next morning, Andy and Jane arrived to check out the state of the car. Thrust had suffered damage to a body panel beneath the parachute tubes. It had been caused by the enormous force of air flowing under the car at high speed. To ensure that it would hold tight, the replacement panel was bonded and riveted into place.
Now the car's been over 700, it's taken quite a pounding aerodynamically, and we want to check every single rivet and nut and weld just to find out what the effects are, because nobody's ever done it before. So it's a safety first, slowly, check as you go approach.
This was the big day. 4 years of development and construction, 2 years of testing, 54 runs so far, but it was still one step at a time. On his first run, Andy was under instructions to achieve a target speed of Mach 0.95. But Andy experienced serious instability, and the car kept veering off course. He aborted the run at 560 miles per hour.
The next thing is for the design team to get up there quickly, check out what's happened, and make the decision as to whether they're going to make another run in the next hour or so, or whether we're going to have to abandon for the morning or abandon for the day.
It was a worrying moment for Noble. The team made adjustments to the tailplane and risked a second run. But within seconds, Andy had to abort again. Back at camp, the press wanted to know why.
I don't know what's happened and why Andy shut it down.
You'll appreciate that testing any high-speed car, whether it be Indy cars or Formula One cars, they take time to check the trim of the car and literally tune it. This is the stage that we're in at the moment. There's no textbook you can get the data from. We're writing the textbook.
Is this an all-or-nothing effort? Well, I think that what worries me is our ability to fund the return trip next year. That really worries me. We had enormous problems getting here in the first place.
So if you don't do it this time around, do you think that's the end of it?
It could well be, yes.
The only option was to return to base. The sound barrier would have to wait for another day. As they investigated the problem, the weather turned against them. High winds swept across the mountains and whipped the desert into a gigantic sandstorm. The team had no option but to just sit and wait. It was just over 50 years ago that aircraft designers coined the phrase the sound barrier, when they found that they experienced an enormous increase in drag as they approached supersonic speeds. Pilots experienced strange, disturbing effects. The controls would shudder violently, lock up, and even work in reverse. Sometimes with catastrophic results. Very little was understood about the effects of supersonic shockwaves when Chuck Yeager flew through the sound barrier in 1947. His Bell X-1 was carried into the stratosphere under the belly of a B-29 bomber. After the X-1 was launched, Yeager fired his rocket engines and accelerated towards Mach 1. He experienced some buffeting and instability, but he kept the controls steady and made it through. Observers on the ground heard a sonic boom. Wind tunnel research revealed the reason for the buffeting and instability. When an aircraft travels faster than the speed of sound, air is compressed at the nose of the plane, and it spreads out into a cone-shaped shock wave. The solution was to keep the wings inside the cone. Swept back wings solved the problem. But even with the new designs, flying supersonic was still an incredibly dangerous gamble. At a British air show in 1952, John Derry was demonstrating breaking the sound barrier when disaster struck. Just as the sonic boom passed over the crowd, the fighter plane exploded in the air. Derry and 62 onlookers were killed as the aircraft smashed into the ground. Eventually, the problems of flying supersonic were solved. In 1967, Pete Knight not only went supersonic, but he flew at over 6 times the speed of sound.
The airplanes are so well designed that they slip through supersonic flight very easily. There is no buffeting or physical sensation. In fact, the only way we know we're going supersonic is to look at the gauges.
Pete Knight became the fastest man ever to fly in the Earth's atmosphere. Amazing flights like these have given aviators a much better understanding of how shock waves behave.
If you take a rowboat in a calm lake or a calm river and row the boat very slowly, you'll see a bow wave start up in front of the boat. As you row a little bit faster, that bow wave attaches to the boat and then sends bow waves off to the shore. If you're standing on the shore, you'll feel that as it goes by you as the water comes up your leg and down. And that's the analogy to a shock wave. As you're standing on the ground and the airplane goes supersonic, it drags a shock wave along with it. And when that shock wave passes you on the ground, it is an overpressure in the air. And you hear it as a bang because it's a quick overpressure.
In the 1950s, the Air Force wanted to find out what would happen to a pilot if he had to eject at supersonic speed. They began research at this 10-mile-long sled track at Holloman Air Force Base. Dr. John Stapp was the willing volunteer.
For the human experiments, this sled was used, and it'll hold 12 rockets. And the highest speed we got with the human was with 9 rockets. And believe me, it's quite a jolt when all of them ignite simultaneously. I was a passive subject for an experiment, and there was nothing I could do except sit there till it happened, and then hope that I'd survive the experience.
December 10th, 1954, Dr. Stapp was tied into a sled for the fastest ride ever experienced on land. He was launched down the track at 632 miles per hour.
It's like jumping out of a window at 10th floor. You feel just completely helpless.
As the sled hit the water break, he felt the impact of minus 43 Gs. A force so powerful, it burst the veins in his eyes.
The permanent effect that I got, and still have, was retinal hemorrhages. I now have implant lenses in both eyes. But I think we succeeded pretty well in showing that the man would survive.
Not wanting to take any more risks with humans, they continued the experiments using chimpanzees. With a chimp strapped to the sled, they reached a peak speed of 920 miles per hour, well beyond the speed of sound. Using unmanned sleds, they continued to increase the speeds to test the performance of aerospace vehicles and missiles. In 1982, they pushed the limits even further. On a night test to avoid collision with any birds, the sled reached 6,122 miles per hour, 8 times the speed of sound.
If you want to think about what supersonic speed is, it means that we're going faster than the speed of sound. What carries sound in the air is that one air molecule bumps into another air molecule. And that speed is controlled by how far apart those air molecules actually are. So when we go faster than the speed of sound, we try to move those molecules faster than they can bump into the next molecule. And what happens is they all pile up, and that's what causes the shock. That shock comes off of a sled, for example, and will bounce off the rail, it'll bounce off this girder, and it'll cause high pressure underneath the sled and won't lift it off. That's why we use slippers to wrap around the rail to hold the sled in place. But for somebody who wants to run a car, the only thing holding them down is gravity and the aerodynamic design of their vehicle. A much more precarious situation.
Aerodynamic experts were skeptical about any car breaking the sound barrier, even the designer of Thrust SSC.
My immediate reaction was, don't be ridiculous, totally impossible. Such a vehicle would never sail on the ground. The aerodynamic forces would be enormous, so I rejected the idea out of hand. I only carried on working on it out of curiosity. If someone was going to be idiot enough to drive at supersonic speeds, what should the car look like?
Ron was eventually convinced by Noble and went on to design the most original land speed car ever conceived. While testing the design on computer, the thrust team also mounted a model of the car on the front of a rocket-powered sled. They then propelled it at Mach 1.15 down the track. When the computer and model data matched up perfectly, the team decided to move forward. But only by building the real car could they test the theory. When Andy kept veering off course at Black Rock, it was down to Ron Ayers to solve the problem. The telemetry data showed that the car was pushing down too hard at the front. They needed to shift the distribution of weight from the front to the back of the car, so they reset the rear suspension and adjusted the tailplane.
It's a very, very smooth surfaces. The car gets a very, very smooth ride. But of course, one of the things you have to bear in mind is the aerodynamic loadings. And as we pass through Mach 1, we'll be up to 3/4 of a ton on every square foot of bodywork.
So far, it had taken over a month at Black Rock to conquer the design problems. But finally, they were confident they could break the sound barrier. Andy Green's cockpit was built with safety as the main concern. The seat was molded to fit his body exactly and placed close to the center of gravity of the car, the best place to feel any instability. But there was one main disadvantage. Unlike the jets that Green usually flies, there was no ejector seat. On the next run, the car accelerated closer to the speed of sound and entered the potentially unstable transonic region.
When the car is traveling at these sort of speeds, some of the airflow around the car is supersonic and some of it is subsonic. And with even a very slight increase in speed, huge areas of subsonic air may actually then go supersonic, and you get buffeting and turbulence and so on. It's fairly unpredictable.
Mile 714.427.
Carried back for the mile, 714.427.
Very nice stable run. We're obviously back in business again, and now let's wait for the next one.
The telemetry readings showed that there were no signs of buffeting, that the car was surprisingly stable, and it was traveling in a straight line. But there was another problem. During the run, both the parachutes had ripped off.
Yeah, exactly. The core's pulled out, so the sheath snapped. The core actually started pulling, and the core held on for a long time.
Well, you think it was 100 yards beyond the bag.
Despite protective covers, the afterburner flames had burned right through the connecting cord of the chutes.
The sheath does all the work, so when the chute came out, it progressively snapped the rest of them round, and the chute came off. And you can actually see where some of them have been melted through. So it's just hotter back there than we expected.
Once again, there was damage to a panel fastener. The team had to make sure that the panels were completely flush to the bodywork. At these speeds, the air would get behind any protrusion and rip it off.
Copy, SSC is rolling. 30 miles an hour, 80%. Hydraulics struggling just a little. And recover. Looking for mill up to 250. It's approaching mill. Sorry, 250. Min burner, the nozzles are stable. Accelerating decimal 9. 500. 590, there's the howl.
Mile 727.860.
Yeah, we're looking for
Carried
738.
back
Pretty good.
727.860.
730 for the killing.
On the button.
Decimal 905, thank you very much.
Approximate Mach number 0.95. Good day's racing.
Spirits were running high, and the car was in good shape. And one of the Microlight pilots had something interesting to report.
There's a tremendous shock wave that comes out. You can just see a mark on the side of the car. It goes out about 20 feet. It's a sort of a white line that dissipates to nothing, probably about 2-3 feet wide. But it's literally 20 feet out and just trailing slightly. And it's really a spectacular sight.
A shock wave is basically just a change in pressure, a rapid change in pressure, but nonetheless a change in pressure. So we can measure it with a pressure sensor. We're measuring all the shock waves and they are very, very stable. The loads on the car don't fluctuate, the shock waves don't move around, so all of the doom and gloom predictions on the car's going to be blown into the air, it will go out of control, it's not happening. The car is very, very stable.
Years of patience had finally paid off. Now it was time to attempt a supersonic land speed record run. The performance of Thrust SSC was to be monitored by the FIA representative, who held a lonely vigil in the timing station 500 yards from the measured mile.
Even if there was a sonic boom, you can't record a sonic boom on a piece of paper. What we can do is we can record the temperature, and we can record the speed. And we can calculate the speed of sound based on the temperature, and then if he's faster than that, then that's the determining factor from the record standpoint.
But the rules for a record are even more demanding.
From the time he goes in the light down here at the start of the mile, he has to go up to the other end, turn around, and go back through this light within less than an hour. I mean, pushing it would be 59 minutes and 30 seconds or 59 minutes and 59 seconds, but that would be rare.
Thrust took 30 seconds to accelerate to 100 miles per hour. In 50 seconds, it had reached 600. In just over a minute, it had covered 5 miles. Thrust SSC finally went supersonic, reaching a peak speed of 766. The spectators heard the sonic boom. But Andy was in trouble.
Look at shoot 1. Nothing on shoot 1. We can shoot 2. 2 miles to go, 400 miles an hour. Recovery, be advised. SSC, double shoot failure. 350, 1.5 to go. Ruled ill on 1.
Once again, the heat of the engines proved too much for the parachutes.
Did you find it? We found it. It appears to be burnt off.
Andy overshot the course by 1.5 miles. Luckily at Black Rock, there's plenty of room for error, but over 15 minutes of the 1-hour turnaround was wasted towing the car back into position. On his return run, using 20 seconds of maximum afterburner, Andy accelerated to 761 miles per hour. Burning more than 4 gallons of fuel every second, the car shot through the measured mile in just under 5 seconds. Despite all the risks, the car remained stable. The team listened for the second sonic boom. The car had gone supersonic in both directions. But their joy was short-lived.
Can you confirm that run was within the hour? Over.
Unfortunately, I cannot do that. You missed it by about a minute.
They had failed to make their second run within the hour.
That is correct.
Yeah, it's a shame. Well, we came close.
Craig Breedlove, whose car Spirit of America was performing badly, arrived in the British camp.
One thing was made very clear between Richard and I, that the first car that went supersonic was the first car to go supersonic, whether it was a record or not. And so today's it. Congratulations.
Thanks, Dave. We've worked very, very hard for a long, long time to achieve this. And an important thing to understand is that a world first is a hell of a sight better than a world record. And we've been very lucky today to actually witness a world first. And we've got the first man ever in the world to drive a car supersonic.
I congratulate them. The only thing I got to say to them is they're second to break the sound barrier. We did it first.
The Budweiser rocket achievement is disputed because they didn't use FIA measurements to calculate its speed.
Nobody questions the speed of the X-15, so I don't know why we should question the speed of the vehicle on the ground using the same kind of instrumentation.
To be the first to do something, that can't be taken away from you.
We sanctioned that, we verified it, and we certified it here at Edwards Air Force Base in 1979.
2 days later, on October 15th, 1997, the world's press arrived at Black Rock to witness an historic event.
This is something that go on your tombstone, when you're eventually 6 foot under, which says, he had a part in this.
In order to claim the first supersonic land speed record, the team knew they would have to break the record according to FIA rules. Winter was approaching, and there would only be a few days of good weather left.
Stationary, SSC is calling.
Timing, go ahead, ready to copy and read back.
Mile 759.333.
I read back 759.333.
Come on. That is correct. Let me see here.
Oh, come on, Charlie.
Give me a second. And
Okay.
Pit station, the provisional Mach number is, say, 1.015.
You've witnessed a supersonic run there. The clock is going now. We've been 5 minutes, 26 seconds since the car entered the measured mile. We've got to be back within the hour. This is where the tension really builds.
This time, they made the turnaround well inside the hour.
Mile 766.609.
I read back 766.609.
That is correct, and a provisional Mach number on the return run, 1.020.
Well, we've just achieved what we set out to achieve all those years ago, eh? It's really something.
Not only had they gone faster than any car had ever run before, but they had achieved a supersonic land speed record of 763 miles per hour.
I watched it from up on top of the hill, and it was quite a sight to see the shockwave out about 300 feet on both sides of the car, and a real magnificent run.
We've achieved one of the best ever land speed records in history at 714. We've achieved the first ever supersonic run. We've now achieved the first ever supersonic land speed record. It's a hell of a campaign, and it's a hell of an achievement.
Thrust SSC is now genuinely the Thrust supersonic car, and this is the first supersonic team. We did it.
What Andy Green did as a driver is fantastic. I mean, it's really remarkable. I know what it takes to do that. I've been there. On the same note, I don't want them to take anything away from what we did.
In London, the crowds turned out to celebrate the homecoming of Thrust SSC. Andy Green was the first man to get a supersonic land speed record, abiding by the FIA rules. But Stan Barrett believes he was the first man to break the sound barrier on land.
The fact is I went Mach 1, and the fact is that I'm the first man to go Mach 1. You know, I welcome him to the club, but he isn't the first person there.